So we're going to look today at graphing by transformations. So when we have some what are called parent functions, so it's kind of what the function would start out with nothing added on. And then it produces, then as I change it or add things to it, like we saw kind of when we did the marble slides, we get a family of graphs. So the parent graph is the basic graph, what it looks like, and then which is made from the parent function. And when we use transformations, we either translate it by moving it, or we dilate it by like change the width and so forth. So there's three parent functions that we're going to kind of work with. Constant function, though, remember, is like that constant, it stays the same. So that's one that we can function that we should know. Identity function is this function that whatever one you put in one, you get one. When you put in two, you get two. When you put whatever you put in, you get. So this is called the identity function. The quadratic function is going to, and we're going to look at these in the next page, is going to be like a U shape. And then we looked at the absolute value function yesterday. So what we're going to look at here is first we're going to identify the function type. So constant function is no slope, just straight line. Identity function starts at 0, goes up 1 over 1, up 1 over 1. And the absolute value function we saw was a v, and quadratic function is when x squared, and it's a U shape. So the first thing we're going to do is identify what is the function. So this is what type of function. So since it has that V shape, you should be thinking absolute. Okay. This one has that U shape. So this is quadratic function. And this is a constant function because it's staying the same constantly throughout the whole thing. And identity function. So our lines are identity. So what we do is we start with those functions here where it starts at these functions, like this absolute value starts right at 0, 0. Right at the origin is the vertex. And then it goes up 1 over 1, up 1 over 1 on the right side, and up 1 over 1, up 1 over 1 on the left side. So if I can just translate it by like moving it, then I can just do this parent graph and just move them around. And the quadratic function is also at 0, 0. And it kind of goes up 1 over 1, but it's the U shape, and then after that it doesn't follow that same pattern, but it's basically that up 1 over 1. It's got a reflection over the y-axis. So very basic today is you have to know the types, and then we're going to look at putting it through transformation. So when it is with like inside with the x. So when I have my number inside the x, then if it's a positive number inside there, right? So then I move it, it moves it that many units to the left. So inside with the x is a movement left or right. If it is a negative in there, inside the x, then it's going to move it right. If it's outside of the parent function, so x squared, if it's positive, it moves it up, and if it's negative, it moves it right. So some examples. If I have the quadratic function, so this translating left would look like f of x and x plus 2. squared. So what I mean by inside, it's in with the x that is being squared. So my parent function is x squared, and I have plus 2 in with that parent function. So that moves it 2 units left. If I had that and it was a negative, and so when it moves left or right, it's kind of opposite of what you think. It would be x minus 4 squared. This would move it 4 units to the right. If I don't have it inside with the parent function, so I have the parent function by itself, and then out here I have something that's going to move it up 5. And if I have it as a negative, it's going to move it down 6. So some absolute values would look like same thing. It's inside the absolute value, then it moves it, and it's positive, it moves it left. If it's inside the absolute value with the x and it's negative, it moves it right. So inside, think opposite. If it's inside the absolute value or outside the absolute value, then it moves it up. And if it's outside the absolute value and it's negative, it's going to move it down. All right. If it's a negative of the parent function, then it's going to reflect over the x-axis or reflect down. But if the negative's inside with the x, then it's going to reflect over the y-axis. So both the quadratic and the absolute value, that reflecting over the y-axis doesn't really change it inside there. So then dilations, if it's greater than 1 times the absolute value, it's going to stretch it vertically, so it's pulling it up, so it's making it skinnier. And if it's less than 1 but greater than 0, so not negative but less than 1, then it's going to compress it vertically, so it's like a push down on it, so it makes it wider. So this is narrow and wide. All right, so a lot of things we're talking about here. So let's look at some things here. So notice the plus 1 is inside with the x, so I'm going to take my parent function on this squared is a u-shaped. It kind of looks like this. That's the parent function. So this plus 1 is going to take this parent function and move it left 1. So this exact function's going left 1. So my, that's not what I want to do. My new function is going to take that parent function I just drew, and my vertex now is going to be left 1, and then it's going to be the U shape. So I'm not looking to have like a perfect graph of it, but I should have a good idea that it's moved, and it kind of goes over 1 up, 1 on each side. After that, it's just a curve. Right? So this one is inside the absolute value. So this is a V-shaped because it's absolute value. Inside there, if it's negative, it moves it right. So it's taking this V-shape original parent function, and I'm moving it right 4. So now my vertex is here, and I'm going to move it up 1 over 1 on the thing. So original, but move it over 4. And it has to be a strong V shape. It shouldn't look like your quadratics, so make sure it's very much a V shape. All right, so now this is a negative outside the absolute value, so it's going to flip it on the x-axis. So if this is my parent function, absolute value is a V shape, then my new function is this function translated over the x-axis, so flipping it down. So it makes those graphs really easy if I can kind of know what the translation is. So this is a U shape, and it's translated down, reflected on across the x-axis. Right? So now we're going to look at some dilations. Dilations then, if this is less than 1, it's going to make it wider. So parent function normally goes up 1 is like this, up 1 over 1. My new function is going to go up 1 over 2. Up 1 over 2. So it is wider because this is less than 1. And it's not flipped because it's positive. So this is greater than 1, so I'm going to actually be pulling it up. Notice I'm going up 2 over 1 on these, so it is a dilation that is stretched vertically. I'm pulling it up vertically. So I want to look at, like, say you have, let's see if I can give myself an empty graph. Say you have like a bunch of things together. You should be able to get to a point where we have like a few things happening. Like I have x plus 2 squared minus 5. So I'm going to, here moves it left 2, because positive in there is left, and this moves it down 1. So I'm taking the original parent function with the U shape. Here's the original one. And I'm not dilating it at all because I don't have anything in there with that x, but I'm going to go left 2 and then down 5. And then I'm going to do my parent function from there. So I can do more than one translation in itself. So that's where we should be going with this.